So you're probably still thinking like, I need to see an example. I need to see an example. These standards, there's a lot to them. So Eric has this beautiful example, and he totally came up with this, but I will tell you, this is actually a really cool lesson that I did a form of this with my my fifth graders when I was teaching computer science as well. Because you're going to see things like using hardware, and you're like, what hardware? This is an easy, fun project that is a simple way to cover so many standards. And then we're even going to talk about how to tack a few more on at the end. So this is a project. This is a project Eric did with his class. This is a project that I did. So we have this existing project. That picture right here, this is a makey board. So this is a cool thing that plugs into your computer because in 6-8, the kids are supposed to be able to use a piece of hardware, something in the real world to control something digitally, okay? So the existing project that we have is using the makey, which is our input hardware, to design a game controller that can be then used to complete a puzzle or a maze in Scratch, okay? So this is our project. This is our initial project. Super fun. It's combining some fun hands-on engineering, super simple to do. Kids love it. So let's take a look at some of the standards, okay? So our computing systems, remember, these are the actual physical devices. Well, we need to figure out how to recommend improvements to these computing devices. And we can ask for input based on how our users are interacting with those devices. My mouse is too small. The controller is hard because my thumbs don't fit where they're supposed to go. We can combine projects or have combined projects that we incorporate hardware and we have software. So in this case, we're using Scratch. That's an online programming platform with the makey. That's the hardware. They exchange data. Systematically identify and fix problems with computing devices. This is going to happen with all of our activities because we want kids not to just say, okay, I did it once, it doesn't work. We want them to say, okay, I did it, it's not working. What do I need to do and fix it so that it will work? So right there with this project, we are covering all three of those standards. All right, so let's bump it up. Let's bump it up a little bit. So we are designing a device or a game controller for a maze that already exists in Scratch, okay? So we are now gonna tie in all these algorithms and programming because we can ask the kids to remix their maze and make it their own. We can develop, we can just take a existing maze and add our own flair to it, or kids can look at the code of a maze and try to make their own, or they can do some research and they can learn how to make their own. They're gonna design a program that will, again, work with their makey to play or move a object through this maze. Now, let's really bump it up. So we just tackled a ton of standards. We're coding, we're solving problems, we're doing some debugging, or we're troubleshooting, but let's add even more standards, right? Because again, we've got lots of tie-ins with other things. And these are like definite guaranteed kind of project boosters where we take something from just being a standalone lesson to having greater impact. We are going to incorporate more standards. We can do that through a competition, who can design the best, the most unique, who can design something using only found objects so that we're not creating any waste. You can tie in entrepreneurship, right? How would you sell this? How would you market this? Who would like to test this and give you feedback so you can improve your project? We can talk at a social justice or equity lens. How can we design a controller that somebody who has maybe a physical disability could use easier? We can incorporate peer feedback, right? Interview somebody, get them to tell you what they like or what you could fix about it. And we can incorporate self-reflection. All of these things are like power-ups to a project, not only because they help you cover more standards, but they make these skills and these resources and these lessons that we're doing more meaningful and tied to the real work that people are using computer science for. So now if we created a survey and collected data from a focus group of game testers, so you made your controller and now somebody's going to use it and give you feedback on it, and you're going to maybe adjust or adapt. Or so we see our collaboration, we just pulled in impacts of computing. Maybe we can get feedback from somebody who, again, has a disability, an accessibility issue, where right now they can't do a maze because their device, their controller doesn't work for their needs. So now we can add something to increase accessibility. Here we go. We've thrown on another standard, all in the same project. We can even add in that discussion of like, okay, so you made this, what should you do with it? Should you sell it, or should you make this free to the public? Should you keep it private? Should you just keep it for yourself? If you shared it, what are some of the things that might happen, right? We got to think about this. We're having this discussion. So all of these things tie into this existing technology project. And most of those things that we just talked about, with the exception of building the maze yourself, are all things that you probably already feel very comfortable doing. Designing a new game controller, talking about how to improve it, talking about what can make it more accessible, talking about the impacts that it could have on society. These are all things, hopefully, that you are starting to say, oh my gosh, yeah, no, I can do it. I can do that. I'm already doing all those things. So we just took this amazing project and covered like 2/3 of your 6 through 8 computer science standards, right? It's pretty amazing. So you're probably thinking, okay, you are talking about all these standards. I'm feeling a little bit better, but what do I use to help me accomplish these? There are a ton of wonderful resources, and I have actually put on here. So code.org, boot up, Scratch, you can see this continuum. The arrow here is telling you who this is a resource for. So code.org, boot up, PD, Scratch Junior, boot up and code.org are K-12. They have resources and less for K-12. Scratch Junior is for your younger students. It's for K2. You would probably use it with 3. We've got Tinker. That's kind of, actually, I think Tinker goes all the way up to 8th grade. CS First and Scratch are ones that you can kind of start with that middle grade. Just because they started a middle grade doesn't mean that they're not for beginners. It's just that the interface is got a little more text, so your kindergartners are going to benefit from those K2 resources because there's less to read. We've got Code Combat, MIT App Inventor, Code HS. You'll notice that 2 of these are starred because those are the only 2 on this list that are not free, which is always amazing. There are so many amazing free resources and robust, amazing resources to help you teach. And even Tinker and Code Combat have free components that you can use in your classes as well. Tinker has a lot of wonderful cross-curricular resources to embed coding into science and math. So does CS First. So these are coding resources when you're looking for those activities that support coding. You can also think about adding in things for programs, for programming, and that hardware software component with robotics and microcontrollers. Again, we can, a lot of these, we can incorporate into our content. Bbot, Botley, CodeMouse, these are for younger students. You can incorporate them into literacy by having kids like program a robot to go to a particular sight word or a particular word group family. We can combine them. Ozobots, I know we use Ozobots a ton. They have just a huge cross-curricular library of activities that we can do coding, and we can do other concepts and other standards that we need to cover. So each one of these is linked. You can explore these a little further. You might already have some of these things in your school district, and you can dig in to see what resources that they have to support you and this journey. Remember, as you're doing your standards alignment and you're saying, okay, do that, need that, here's where these resources might come in handy to fill those gaps.